Okay, so now let's do part B. We got to find the percentage of this speed, 4.4 times 10 to the negative 8th meters per second. We have to find the percentage of this speed to the Earth's speed as it goes around the Sun, sort of to give you an idea of how significant this is. So we're supposed to use this distance right here as the mean distance from the Sun. In other words, that's the radius. So that's radius from the Earth to the Sun. That's 1.5 times 10 to the 11th meters. And we're going to just assume, if this is the Sun and this is the Earth, that the orbital path of the Earth around the Sun is pretty circular and not lumpy like I've drawn it right here. And then there's that R. Okay, so the easiest way to find the velocity is just do distance over time, assuming that the Earth's moving at a pretty constant speed. That distance is just the circumference, so that's 2 pi times 1.5 times 10 to the 11th meters over the time, which is the number of seconds in a year, which is 3.15 times 10 to the 7th seconds. If you wanted to figure that out, you could just multiply 60 seconds in a minute times 60 minutes in an hour times 24 hours in a day times 365 days a year, and it'll give you just about that number. Alright, now we take this difference. You can see right now, just by the order of magnitude 11 over 7th, we're going to get something times 10 to the 4th. This up here is roughly 9. This down here is roughly 3. So we're looking at about 3 times 10 to the 4th meters per second. Alright, and now to finish up, we're just going to compare these two numbers, and to do that we're going to take, oh, something's going on here, there we go, 4.4 times 10 to the negative 8th meters per second, and divide it by 3 times 10 to the 4th meters per second to determine the relationship between the two, and that number is going to give us 1.47 times 10 to the negative 12th. To convert that to a percentage, we just move the decimal over 2 spots, so we're going to get 1.47 times 10 to the negative 10%. In other words, the change in Earth's orbital velocity here for that collision is extremely, extremely small.